Okay, hi and welcome to part 2 of our notes today. This is 1.3. In the last notes, 1.1, we reviewed what a variable would be. So we could kind of talk about it. It's one of the base pieces of algebra. Don't get me wrong, there's a lot of them, but that's one of the first ones we really should see. So now that we're talking variables, we really should move along and talk about our numbers. And that's what we're going to do now is take a look at what different types of number sets there are. Again, this should count as review and some vocabulary built in here, so things that we can use later that we'll talk about throughout the year. We're really just going to explore these number sets really quick, but you should be pretty familiar with them, so this should go kind of fast for us. All right, so the natural numbers should be the first number set that we're going to talk about because these sets of numbers contain different parts to them. And the natural ones are the ones that naturally come to us, meaning that it would be ones that we count on our fingers and our toes. So if I'm looking at my hand, I don't have a hand in front of you on the screen, but if I was looking at my hand, I'd hold up a finger and you would see that there is one finger, and then I could put up 2 fingers and 3 and toes if you'd like. I got 4 toes. I hope I have 4 toes. Actually, I hope I have 5 toes. But I could count all those. But in doing those countings there, I don't ever count half a finger at this point. I don't count negative fingers, meaning missing fingers. Same thing. But these are what we'd call the natural numbers. And you'll notice that I didn't include 0 in this set because it's the natural numbers, numbers that nature would produce. Nature can't really produce 0 of something. If it did, we wouldn't count it. So you can help to think of it that way. So the natural numbers quite literally are the whole numbers, positive side, so and not including 0. So that's your natural numbers. It's denoted by the symbol as a bold N. So that's what we'll use to decide to show that. And in bold, when we're writing, we don't actually bold it. I just do a double line, which indicates that it's bold. So let's move on to the whole numbers. The whole numbers are very much like the natural numbers. It's us starting to make sense of the numbers, and we're going to include 0 because 0 is a very non-important number. It's a very important number that we need to keep track of because knowing that we don't have anything is just as important as knowing how many things we have. So the whole numbers then are going to be denoted by a W or a bold W. Okay, moving on to the integers, one of our favorite sets of numbers to work with because it's the whole numbers and it's the natural numbers and the whole numbers. So let's write in what we added here. So we added 0 here. And then in the integers, we're going to add in negatives. Okay, so if we look at these, we get the whole numbers, the natural numbers, and now we start talking about negatives. Okay, we can also, I guess, talk about the fact that in here we can have special fractions, certain fractions, fractions that indicate a whole number. So if you want to start talking some ratios, we really don't include ratios there or fractions there. That's where we get to the rational numbers. So we're going to include fractions slash ratios because that's kind of the same thing, right? We include fractions and ratios. So now in the I didn't give you the integer sign. And the integer is kind of tricky because it's not what you would expect. You'd expect a bold I, right? We got a bold N for natural numbers. We got a bold W for whole numbers. But integers, the way that it worked out, is a bold Z. And that's not a very good Z there. Let me see if I can duplicate that a little bit better. And that doesn't want to erase. All right, well, we'll do it over here. There's your bold Z. I cross mine with the middle sometimes I don't. It just matters. So we got N, W, and Z. Those represent those sets of numbers that we're building up. And notice that they're getting more complex the more we go. So let's talk about the rational numbers. And this is where we'll spend a lot of our time, is in the rational numbers, because it includes the zeros, the whole numbers, right? It also includes the negatives, the integers, right? So they're all a part of these rational numbers. And then we start to include, and I'll do a different color here, all of the decimals in between each of these. So that's where the fractions and the ratios come into play. So basically, if we wanted to, we could just highlight this whole line, and that would include all of the numbers that you could possibly see there. Rational numbers, again, kind of confusing, are indicated by a Q for this one. Let me see if I can get that to, let me get my line up here. So a Z, there's my bold Z. All right, so there's all of our main subsets of numbers. We do spend a lot of time here and here because sometimes we want to talk about negative and positive whole values, and then we want to talk about all negative and positive values. We'll talk about the rational number. Okay, let's move to our last set here, which we're going to call the irrational numbers. So we know that these all are concluded together and they kind of build on each other. We go from just numbers we can count on our fingers, the natural numbers, to the whole numbers, which adds 0, the integers, which adds negatives, the rational numbers, which adds fractions and ratios. The last set then is a set that doesn't fit inside of that. It's not something we can add to it as in layers. So you can see the rational numbers here. They're kind of in layers. This set is what we refer to as numbers that don't end or repeat. No end or repeat. Now, these are usually, and you can already probably think of a few, numbers that you know. Pi is commonly, right? Isn't that Pi Day where you sit there and you try to memorize all the numbers of pi, all the decimals of pi? It takes quite a while. And most square roots. Now, there are other numbers out there, but those are a vast majority of where we're going to spend our time with those. And those irrational numbers, as we suspected, would be a bold I. So, together, all of these numbers, if we mix all, or we'll say the rational numbers, which includes all of the other subsets above it, and the irrational numbers, which don't really fit because they don't end or repeat. And think about that. If they don't end or repeat, they're a little bit more difficult to work with. We cannot round them, and we always get a changing answer. So that's why they're their own subset. If we put them all together, we get what we call the real numbers. And that's really where we spend our time. And the real numbers get its nice fancy bold R. Okay, so we spend most of our time in the real numbers, but we do spend time in specific subsets, especially integers and rational numbers. We'll spend a lot of time in there. So let's take a look at some numbers here and see if we can figure out what subsets they belong to. And they may belong to more than one subset. So the first number we're going to look at is negative 17/31. If I go ahead and put that in my calculator, I don't know if you can see that. I'll scroll it down here. You'll see that that decimal does not look like it's ending or repeating. So in that case, we're going to go ahead and say it belongs to part of the irrational numbers. Well, let's look at 23 then. 23, can we find it in the natural numbers? Yeah, it's a number we can count on our fingers and our toes plus our friend. Our whole numbers, add 0, it's still there. Add the negative numbers, it's still there. On the positive side, add the rational numbers, it's still there. So it really belongs to just about every set except for the irrational numbers. So in this particular question, we'd put a bold N, we would put a bold W, we would put a bold Z. Sometimes the Z's and the I's get a little close, so be careful. And it belongs to the rationals as a bold Q. Now look at 0, though. 0 does not belong to the natural number set. It doesn't exist in that one. So we did basically the same thing minus the natural numbers there. All right, so 4.581, it may continue, but in this particular form, it ends after 3 decimal places. So really, this one's just going to be a rational number. It doesn't exist in the natural numbers because it's a fraction. Same thing for the whole and the integers because it doesn't fit in there. It's specific to the rational numbers. And the square root there is going to be an indicator that this is most likely an irrational number there. Now, there is another set of numbers that we will explore lightly, which we call the imaginary numbers, which I think I spelled that incorrectly, but you get the idea. The imaginary numbers are numbers that do exist in a different plane. We have to think them as slightly different. So we'll save those for when we get to quadratic. So that's a little ways away, so don't worry about them yet. But you will be introduced to a different set of numbers out there. All right, so let's see if we can see where these subsets kind of make sense in questions that you're going to be asked. So it says, suppose that 110 students are going on a field trip. Each bus can hold 40 students. To find the number of buses needed, what number set best describes the situation? Reasonably. So here's the question that it's posed. We've got 110 students. Let me move my calculator up a little bit here. We've got 110 students. If it turns on, there we go. That we need to divide up into 40 buses. So let's go ahead and do that division so we can see what number comes out. And it's 2.75. So it's roughly 2 3/4 of a bus. Are we going to drive or use 3/4 of a bus? No. Can we go down to, well, so that means that we really need a whole number for this, right? We need some version of a number that's a whole number. It can't be 0 buses, so we're going to leave the natural numbers out. So the most likely subset that we're going to use for this would be the whole numbers, because it's only going to give us whole buses, not including 0. We don't care about negative buses, so we don't care about integers. We don't care about or the rational subset because it would give us portion of buses where we're at. So, I mean, the answer to this would be 3 buses because you got to go up to make sure there's enough buses or people to fit on the buses. So we'd have to go up to 3, but that's not the important part. The important part is that the whole numbers in this scenario is a subset that we'd want to use to explain this. Okay, so to keep this video short, I'm going to go ahead and stop there. If you have some questions on these, you can ask me about them in class. But I think you get the concept if I do one quick example there. You're looking for the subset that makes the most sense. All right, we'll see you in class.